Hi, and welcome to Supermicro Tech Talk. Today I have with us Paul McLeod, Product Director of Super Storage. How are you doing today, Paul?
I'm doing pretty good. So again, great to be here. And what I'm proud to introduce today is that through all the challenges of 2020, that we have one of the most powerful top-loading storage servers that was produced during that period of time. So again, the development and a lot of the work to make this happen was through COVID. So really excited to bring this to this event, as well as getting to see some future benchmarks. We think that this thing is going to be record-setting because of all the enhancements happening in the X12 line.
So that's quite an impressive achievement. What can you tell me more about this?
So this is our latest product. We've been working with top-loading storage for about 6 years, and through that we've had lots of feedback from customers, and we've come to this design, which is available in 60 bay and 90 bay configurations. And those kind of configurations are kind of the sweet spot in the market. There are some that could be a little bit larger, and there's some that could be a little smaller, and we have other products that will cover that space. But the big achievement in this is it's a modular design. So it's kind of inheriting Supermicro's DNA, which is everything is modular and can be reused and reconfigured, so we have multiple configurations inside this chassis.
That's excellent. So what are some of the different configurations?
So as you can see, I've got a server node up here. Again, that's the modular server node, and I'm going to rotate here so you can take a look at the back side of this, which has a single node configuration. In the single node configuration, we have a feature set that would be NVMe and boot drives, and essentially a server footprint built for one very large storage server, right? A lot of capacity coming out of one server. So we have a bunch of NVMe and caching features. The other configuration would be called a dual node. So this you could think of as being like our twin family, where the two nodes live in the same chassis, but they're two completely independent servers. So they don't share the storage. They have their own drives cut between the 90 and the 60 bay storage bays. And that is a key for certain applications where they really want to have more compute power than storage, but they still need this very dense 3.5-inch storage infrastructure. Then the final configuration we call SBB. It's basically an industry term for a high availability storage server, where you have both nodes talk to each other. So they are synchronously talking to each other. We have actually a PCIe bus that goes between the nodes so they can have a high-speed communication. And they both see all the storage. So if one were to fail, the other one could take over. So it's really kind of a powerful footprint here, covering all these different kinds of applications and ground within one chassis.
So that's quite interesting. How about you tell me a little bit more about the main drive bays on this server?
So this has a drive drawer design, which gives us the ability to access the drives without moving the server that's well secured in the rack. It supports 3.5-inch and 2.5-inch drives, all hot swap. The drive tray, we've been shipping this drive tray for a long time, so it's proven to be a very field-proven design. And the new feature of this design is that we have these expander trays that are field replaceable. So this gives us, again, much greater serviceability and allows for a single person in the data center to manage this system.
Fantastic. So what happens when something fails?
That's a good question, because again, one of the things with these systems is that there are a lot of components, and you have to be able to get the active components out and leave the infrastructure there, especially when in our SBB design, where you have a system that needs to stay 100% online, and you don't want any interference. So in those systems, all this hot swap capability is mission critical. So my server node can be pulled out while the system's fully running. My expanders can be pulled out while the system is running. It's all hot swap, no single point of failure. So it's really a great addition to our SBB line in that configuration. As I said before, we have an internal cable management arm in the drawer. That removes the cable management on the back of the system, which usually becomes difficult for engineers in the field to be able to manage. So without the cable management arm, I can get to my server node, I can pull out the server node, and I can replace it with another if there's a problem. So pretty much much better server management and hardware management on this system than in previous generations.
I can definitely see that. So what are some of the use cases for this server?
So we're probably all aware and have heard the buzzwords big data, or as maybe it's more traditionally called, unstructured data. Unstructured data is pretty much everything that all of us are creating every day, right? Every time you touch your phone, you're creating some piece of this unstructured data. And that's going somewhere, that's being stored, and it's getting more and more valuable. So a system like this is designed to store that. And one of the things about it is because it's getting more valuable, it's both coming in quicker and it's being stored longer. So all of these high availability features this server has are there to benefit that customer, so they can deploy this for a long time, analyze that data, and get benefit from it. The other area where this shines, again in that HPC market space, is that SBB. So SBB being high availability, I can do high-speed data analytics on a very large footprint with a system like this, leveraging other Supermicro products like our GPUs and everything else.
Absolutely. Tell me more about X12 and the integration of Intel's third generation Xeon Scalable processor.
The advent of this next generation of Intel technology, we get more horsepower. Of course, we're always waiting for more horsepower on systems, and this is no different. So this server is a dual Xeon system. So we have a lot of cores. We can support up to 205 watt TDP, so that's really high up in the processor stack. The ability to do workloads that differentiate Supermicro's top loading storage from everyone else's has to do with that, having more horsepower to drive those workloads. And we're the leader. There's nobody else that even comes close. Systems like this usually have embedded processors or very lightweight processors, so you're not going to be doing much computing on them with those kind of architectures, whereas this, I can converge my workload onto the storage if that's desired. The other thing we have with this generation of Intel technology is PCIe Gen 4. So with Gen 4, we're opening up our networking side, right? This has a SAS infrastructure that is a generation of SAS that is very robust and stable, and we've got a lot of bandwidth there that actually would bottleneck at the front of this. So on the front end, the networking side, I now have PCIe Gen 4, meaning I can put 200 gig cards in this system, and I can have two of them. I can have one for one processor and one for another, and get a very good bandwidth in the system.
So with all this additional bandwidth, it sounds like this server is well prepared for future storage media.
One of the innovations that's happening now, spinning drives have kind of reached a point of saturation. But the drive vendors realized that a long time ago and started working on things with new techniques to get more performance out of a mechanical device. The mechanical device is still deployed and is the #1 way to store unstructured data because it's cheap, right? So essentially people still want this kind of device to store their data economically. So with the next generation, they're going to have dual actuators, they're going to have more bandwidth available to the individual drives. And we thought of this in advance and architected all of our SAS topology to support the next generation of hard drives. Another thing that we think could be occurring in the market is, of course, lower cost SSDs, in which case we can support that here as well. There's a couple of vendors out there that are doing these very dense SSD devices in 3.5-inch format. And again, we're ready for those vendors as well. So this becomes the infrastructure for next generation.
I love everything I've heard. This is really great technology, Paul.
Yeah, customers have come to expect cutting-edge technology from Supermicro, and also the best value, right? So they're getting this very high-end technology at the very best price. And again, the new generation top-loading line really delivers this for our customers.
Absolutely. So thank you so much, Paul. This has been exceptional information. And thank you all for joining our Supermicro Tech Talk. Learn more at supermicro.com/X12, powered by Intel.